Hello, everybody. Thank you for joining me. My name is Salomon BRYS, and today we'll be talking about advanced multi-platform dependency injection. So before we go to the main topic, I just want to mention that I founded Kodein-DI, which is a European company dedicated to Kotlin multi-platform. It was the first European company to be certified by JetBrains for our Kotlin multi-platform, our Kotlin trainings, and we offer various Kotlin multi-platform consulting services. The flip side of Kodein-DI is its open source counterpart, the Kodein framework. The Kodein framework is an open source initiative aimed at delivering a set of high-level libraries to facilitate multi-platform application development with Kotlin multi-platform. So most of the libraries inside Kodein framework do target all the Kotlin multi-platform targets, meaning Android, iOS, the web, server-side, and desktop clients. Today, I'm going to be talking about Kodein-DI, which is our painless dependency injection library, which do target every target that Kotlin itself targets. So, what is dependency injection? Well, this talk is titled Advanced Dependency Injection, and I only have 40 minutes. So I'm going to assume that you know what dependency injection is. I just want to show that, to me, dependency injection means organizing what do I have and what do I need. And those two questions leads to more questions that are important to answer correctly when you use dependency injection. And the most important question, of course, of them all is, how do I debug and understand this process? If everything is magic, then when something goes wrong, how do I understand how does it go? And I hope that this presentation today will help you answer those questions with Kodein-DI. So let's go right to the topic and declare bindings. Now, you can declare multiple types of binding in Kodein-DI, the first of which is the provider. When you bind a provider, you give a lambda, and this lambda will be called every time a new instance is required. Now, the contract of the provider is to return a new instance every time. You can bind a factory, which is basically a provider with an argument. The type of the argument is left to you and is part of the binding, meaning that here, for example, I bind a user API factory with a string argument. So to retrieve this a user API, I need to ask for an instance with a string argument. The most renowned binding in DI is, of course, the singleton. The provided lambda will be called once and only once, and the resulting instance will be cached by the DI container and returned at each request. You can also bind an instance, which is almost like a singleton, but it's an instance which exists before the DI container already exists. So its existence predates the existence of the DI container, and you can simply pass an existing instance. And finally, there's the multiton, which is a singleton, but with a parameter. So the provided lambda will be always called for a new secret argument in this instance, meaning that if you request multiple times an instance with the same secret, then the lambda will be called only once, and then the DI container will cache the instance according to the argument. Note that here we haven't defined the types that we are binding, because these types are inferred from the lambda return type. But sometimes you are binding a concrete class to an interface class. So in the application, when you will be retrieving those dependencies, you will be requesting the interface. And for that case, you do need to define that interface. To be precise, you don't need to define it if you are on Android, because JVM allows for more magic than the rest of the Kotlin multi-platform targets. But if you are targeting Kotlin multi-platform, then you do need to define the interface you are binding. And there you have it. These are the main types of binding that you will find in Kodein-DI. So what if you bind twice the same type? For example, here I'm binding two strings. One is the base URL of my API, and the second is my credentials. So this will, of course, lead to an error, because you cannot bind twice the same type. So you need to differentiate them. And for that, you can use tags. Tags is just a way to say, OK, I want a string, but I just don't want any string. I want the API URL string, or I want the credentials string. Now, this particular use case is covered by the bind constant function, which is actually the same as bind instance. The only difference is that bind constant requires you to use a tag, and is usually used for strings and other types of constants, such as doubles, long, etc. So now that we have bound our dependencies, how do we access them? And Kodein-DI supports two ways of accessing your dependencies. You can inject them as constructor parameters, or you can lazily retrieve them at call sites. So let's start with the injection. Let's say that we have a user repository class, and that user repository has two dependencies, a database and an HTTP client. So binding them is pretty easy. We bind all these three classes as singleton. The question is, how do we pass parameters to user repository? Kodein-DI has a method called instance, and that instance method is requesting the instance from Kodein-DI, and with that, Kodein-DI will find the right instance corresponding to the right binding of the right type. So you don't have to tell, OK, I want an instance of DB, HTTP client. The magic of Kotlin type inference makes the syntax pretty easy. So that's how you inject dependencies as constructor parameters. Note that the user repository class is absolutely unaware of Kodein-DI, and that's the upside of this method, is that you can use any class as long as its dependencies are taken as constructor parameters. It doesn't have to understand that it is getting those dependencies from a DI container. So let's get back to our user repository, and now let's make it aware of the DI container by using the DI aware interface. DI aware requires you to have a DI container. Once you have that, the class can be responsible for declaring its own dependencies and retrieving them via this by instance syntax. So let's say that we have a function that uses one of our dependency, here the database. What's interesting is that because we are using the by keywords, the database is actually retrieved from the container at call time, the first time the database is accessed. Now, this is important, especially on Android, because most of Android component classes, such as activities or fragments, aren't embedded inside their application when they're created. You need to wait for the onCreate lifecycle event. And with that, you don't have to do anything, because the dependencies are resolved when you call them the first time. Then it works lazily, and you don't have to do some kind of Android magic. So you bind those classes, those types. So what do you put inside as the user repository constructor parameter? It takes a DI object, so you simply pass the DI object. And with that, you can have a class that is aware of the DI container and can retrieve its own dependency lazily when it needs it. So let's go back to declaring our dependencies, because I want to go a little bit further inside these advanced use case that I promised. So we are going to take as an example these four classes. So application parameters is the parameters of our application. So maybe the API URL, the database file path, all that. We have two business classes, app HTTP client and user DB, which both take app parameters as constructor parameters. And we have a user repository that takes both the DB and the HTTP client and binds all that together. So we declare our instances, our bindings, pretty much like this. The problem with an application is that it can contain lots of bindings, and these don't feel really organized. So you can create modules and move those bindings inside these modules. And suddenly it feels more organized, and you can have different teams maintaining different modules. Of course, you do need to import those modules inside the container, the DI container, when you are declaring it. So we have a container with our own internal module, which contains multiple things, including our production parameters. How do we test that? Because, you know, some people think that testing is important. So how do we do that? We can create a new container, test container, that imports the same module. However, we need to change the parameter, the application parameter. So how do we change the application parameter? If we do bind a new instance of application parameter, it will crash because we are overriding an existing instance. So instead of having multiple modules and only a module that is not imported in test and is overridden in test, you can simply say, OK, I'm overriding an instance. I'm overriding a binding, and I know I am, and I'm doing that for a good reason. And that means that you can now assert that your app container contains the app configuration, and your test container contains your test configuration. You can override bindings, and that can be very useful when you test. Because in unit test, most of the time, you are overriding one thing because you are testing just one other thing. So it makes testing a lot easier. You can also, instead of stating that you override every binding, you can ask the DI container to allow you to override without explicitly specifying it. This is very useful, but I urge you not to use that outside testing because it can lead to very, very weird errors. So we've seen that a module declares bindings, and I want to talk to you about extension that creates a new DI container. So let's say that we have our DI container that binds a singleton of type user repository, and now we can create a sub-DI. So it's another container. We can create another container and import from inside that container all binding that exist inside another container. So here, if I get a user repository in both the main and the sub container, I can say for sure that both will contain the exact same instance. Because sub-DI, the sub-container, when asked for a user repository instance, goes back to the main and asks for it. However, if I override this singleton inside sub-DI, then, of course, I will have two different instances. So sometimes you'll have the same, sometimes you won't have the same. It depends on if you override. And this leads me to the copy strategies. When you extend an existing container, we use the copy strategy by default called copy non-cached. So bindings that are copied represent new instances, and bindings that are not copied represent references to the parent instances. So if you use copy.all, then the singleton binding will be copied to the child container, and then you will have two different instances. Because it will not be a reference to the parent container, it will be inside this child container. If you don't copy, for example, by using non-cached, then the child container will get a reference to the parent container, and the instance will always be the same. You can customize this behavior, and you can use none, all, or custom. So non-cached basically means that it will copy all bindings that are not cached. And a cached bindings is a singleton or a multiton. It's a binding where the instance is cached by the bindings. So you can customize that, but be careful, here be dragons, and please refer to the documentation if you need to. So I hear that programmers make mistakes. So Kodein-DI has you covered if you're one of those. Here are the most usual type of errors that you will find. The first being a binding not found. So you create a DI container, you import all your modules, and you retrieve an instance. So that works, but what if you forgot to import a module? Kodein-DI will tell you, OK, I didn't find the binding, the instance that you are asking for. The thing is that sometimes you're going to yell at your computer and saying, yeah, I'm pretty sure that I bound this. So you can use full container tree on error, and full container tree on error will show you, will dump the entire bindings, the entire container, and you'll see all the bindings that are in your container. And here you can see that we only have one business model, so we probably forgot to add in another binding, another module. The other type of classic error that you'll get is that you're overriding an existing binding. Here, for example, I'm overriding the user repository binding without explicitly stating overrides equals true. So it will tell you, OK, you are overriding a binding. Please don't do that. And as I've told you, the fix is pretty clear. Just use overrides equal true. And the last type of classic error that you'll get is binding recursion. So here we have three classes, all depending on one another. And when we ask the DI container to give us an A instance, it will give us a dependency loop exception stating that it counts because A depends on C, which depends on B, which depends on A. So sort your mess out before asking for impossible tasks. So let's talk about scopes. A scope defines the lifetime of a singleton or multiton. Things like user session, session controller, etc. Basically, you want a singleton in a sub-part of your app. Maybe you have an activity and you want to have a singleton inside that activity, but you want different instances inside different activities, or the same goes for a server session. And Kodein-DI offers that, and it already offers existing scopes and functionalities for various platforms and frameworks, such as Android, Ktor, TornadoFX, and Compose for Android, and Compose for multi-platform. But let's say that we haven't got your use case covered. Maybe you're using another web server API, and you want to create your own scope. How would you do that? So a scope is an object. And the easiest way to create a scope in Kodein-DI is by using weak context scope. So here, for example, I'm supposing that I want to create a session-based, so I'm thinking server session-based scope. So I want to have singletons that are unique inside a session, maybe a user API, but I want different user API bound to different user sessions. This is the easiest way to create a scope. It will keep a weak reference to the context, here the session, and once the session is garbage collected, then everything that in this scope will also be released and garbage collected. However, it's not the most correct way to declare a scope, and to understand why, you'll need to wait a few slides. But I'm going to show you how we can create a correct scope. We need, of course, to implement the scope interface. And we need to maintain a map or a list or whatever of scope registries. A scope registry is where the singleton instance will live. Here, for example, I'm assuming that a session has a string ID, so I'm maintaining a map of scope registries bound to a session string ID. And the scope interface asks you to provide this function, getRegistry, which must return a registry according to a context, and the contract is that you will always return the same registry when provided with the same context. So it's pretty easy. We retrieve, we get or put a registry inside the map, and we return it. However, this is not good. We just created a huge memory leak. Now we have a strong reference to a string ID, so the session will be reclaimed, garbage collected, but the scope registry will never be garbage collected. So what we need to do is to register a callback or whatever to remove the registry when the session is closed. Now, this session.onClose is specific to your framework, so it will not always look like this, but this is the idea. You need a way to remove the scope registry once the context is ending. And what sets apart this implementation from the weak context scope that I've just shown you is this registry.clear method. The weak context scope doesn't call clear on registry, while if you implement your own scope, you can and should call clear on the registry. And what does it do? We'll see that in just a bit. So how do we use a scope? Well, when we bind a singleton, we are actually using a sugar syntax that looks like this, desugared. So you need to desugar the syntax. Instead of calling bind singleton, you need to call bind, and inside the binding singleton, okay? And now you can add the scope. Because the scope is an object, it's really easy to add a session scope or whatever scope inside a singleton. Once you've done that, you can access the context of the scope inside the singleton lambda. Here, for example, maybe the user API needs the session ID, and you can simply access the context by using context. So this is cool if you are retrieving a user API with a session context. And we'll see how to do that just in a bit. But maybe the context is something else. Maybe the context is the request. And what you can do is tell Kodein-DI, well, if you have a request context, then you have a session context, because I can translate a request to a session. So you can register context translators and tell Kodein-DI, well, I can transform any request to a session. So now you can request a user API. You can get a user API interface with a session context, but you can also get a user API instance with a request context, because Kodein-DI knows how to translate request to session. So now that you've bound it, how do you retrieve it? Well, when you're using a DI-aware class, there is a default context, and that is the class itself. The class itself is the context. So maybe you registered a context translator that can translate a container to a request, in which case you're done. Maybe you didn't, and you need to define the context explicitly, and you do that by using the onContext syntax. Now, let's see our user API class. It gets an ID as a string, and which is the context ID, the session ID, and it opens a log file to log every call that is made to this user API. This is pretty useful, but now we just created a resource leak, because the log file is opened and never closed. So how do we close it? We can use scope closable. Scope closable says, OK, if you are bound as a singleton inside the scope, then when that scope clears, you can close, and I will call close. So with that, your user API, being scope closable, will be properly closed and can release the log file resource, and you can be sure that the log file will be closed. However, it only works if your scope clears its registry, which is why I encourage you to go the mile further to implement your scope in a correct way rather than using weak context scope. If you don't have scope closables inside your scope, then use weak context scope. It's easy, it's quick. But if you need the scope to clear, the scope registry to be cleared, because you have scope closable, then you'll need to implement your scope in a way that clears the registry when the context ends. So that's it for scope. Let's talk about declarative UI, because there's this new hot stuff. There's Jetpack Compose, there's Swift UI, and Kodein-DI loves declarative UI. So with Jetpack or JetBrains Compose, because we support Compose multi-platform, you can easily put a DI container as a node of your Compose tree. You can say with DI, and then pass it a composable content, and all that content will have a DI container to use. And inside the content view, you can simply use your local di.current to get the DI and then get instances that are bound inside your DI container. So that's pretty useful, and what you can do furthermore is declare a sub-DI. So we've seen that you can extend DI by composing them and having a new DI container with new bindings that extends an existing binding. With Compose, you can use sub-DI, and sub-DI will create a new DI object, extend a new DI container, extending the existing container in the tree. And from that, you can bind new instances. So I've just said that you can access the DI container with local DI. And I kind of lied. You can do that, but you really, really, really should not. That's because these app parameters by di.instance will be resolved at every composition. So that's a performance issue, right? Well, that's not the reason why you shouldn't do that, because it turns out that Kodein-DI is pretty much optimized, and once you've made a request, it knows where the binding is, so it's pretty fast. The reason why you shouldn't do that is that because if app parameters, for example, is not a singleton, if it's bound as a provider, you'll get a new instance every time. And the contract of provider is not to get a new instance at every recomposition. It's to get a different instance every time you request one. And here, the assumption is that you'll always get the same instance. Because if you start, I don't know, an async task and then look for this async task, if you have different object, then everything breaks. So what you really should do is use remember instance. You don't even have to get this local di.current. Just use remember instance. It will be kept. The result will be kept as a state, and you will have correct semantic. We support Android specificities by not requiring a DI object to exist, a DI container to exist inside the composable tree, by allowing you to have either your fragment activity or application to be DI aware. Here, the example is the activity, but in the vast majority of your application, it will be the application who is DI aware, because you'll have one DI instance, one DI container for your whole application. And when you need a DI container, you can use Android Context DI. And what Android Context DI does is look for the DI container in the closest component, meaning the framework. If the framework isn't DI aware, then the activity, and if the activity isn't DI aware, then the application. However, the syntax you'll be most using is simply remember instance. And remember instance works the same way on Android. It will first look for a DI container inside the compose tree, and if it doesn't find one, then it goes up to the first container, so the Android component, such as the fragment or the activity, and if it doesn't find one, then it goes to the application, and if it doesn't find one, well, it tells you that there's no DI container to be found. So with that, you can have your DI container declared as inside your Android application, and then use it as is in your compose tree without without adding it to the compose tree or doing whatever. We have you covered with our Android framework specificities. So how about Swift and Swift UI? The work in progress in red means that it is not released yet. It's a work in progress, and to be honest, it's even more of an idea in progress because we've just started working on that. But I want to show you what the future of Kodein-DI look. We want to support Swift and Swift UI, and we want to support retrieval, meaning that we want a shared Kotlin multi-platform business core to be able to expose a DI container, and we want the Swift code to be able to retrieve instances, whether in Swift or in Swift UI. And we also want Swift to be able to declare their own bindings to make it on par with Android. So on Android, you can add your own modules because you're using Kotlin on Android, so it's really easy to add application modules and then to use this DI container for business logic as well as for your own application needs. You can't do that with Swift and Swift UI at the moment, and we want you to be able to bind Swift classes, Swift types inside the DI container and retrieve them in Swift. And so to do that, we need a way to distribute a compiled framework with a klib. However, that's not going to happen. JetBrains has been vocal in acknowledging this limitation and stating that it will not be lifted anytime soon. That's because in a klib that there's the Kotlin multi-platform native intermediate representation, and when it gets compiled to a framework, then the module of the name of this framework, the module name of this framework changes every time according to your application. So to move further, we need a way to distribute Swift sources with a klib, a way to modify these sources according to the app module, basically to modify just the import at the top of the Swift file stating, okay, I need to import the framework that contains the Kodein-DI compiled code, and we need a way to compile these sources alongside the framework compilation. We are currently working on a Gradle plugin that does that, that will allow us to ship Swift sources and will allow you to retrieve those Swift sources, modify them automatically, and compile them alongside the framework. We have a proof of concept in the work, and so stay tuned. It's not going to be for tomorrow, but who knows, maybe for the day after tomorrow. Another thing that we are looking forward to is the idea that instead of using these instance methods, you could be able to create your own dependency interface. So what we want to do is give you the ability to have completion exhaustiveness check. We want, instead of using a DI container, you could use your own dependency interface. And now, a compiler plugin that would implement this interface, when implementing this interface, would know exactly all the bindings that are needed for this interface to answer correctly to every method. And so we can, when verifying a new instance of a class implementing this interface, we can add a check stating, okay, does the DI container that I have, that I'll use for this facade, contain all the dependencies I need? And so instead of getting a DI object, you'll get your interface, your dependencies, and you won't be using a DI object anymore. So everything that you'll need will need to be declared inside that dependency interface. What we won't be doing, for sure, is having the same kind of stuff going on for declaration. We really like this DSL. We really think that it's easy to understand and that it's flexible and that you can do a lot of stuff with that. So we want to provide an interface for retrieval. We won't provide an interface for declaration, for bindings. So this allows, as I said, completion check. But there's one way that it's not yet complete. It's because here we are using instance, and that can still crash. So we also need a way to state, OK, this module will work with this dependency interface, and now we use HTTP client, the method HTTP client. And with that, you can easily see that a compiler plugin to generate retrieval interface allows completeness and correctness checks, which can be performed as a simple unit test. So instead of running through your application, launching every screen, every activity, touching every button, and making sure that everything is wired as it should, you can now check that everything is wired as it should just by launching a simple unit test. And it makes retrieval semantic, which is really cool, because instead of requesting an instance, you're requesting an HTTP client. However, it needs a compiler plugin API, so we are currently exploring the unstable compiler plugin API. We are also exploring KSP, Kotlin Symbol Processor, to see if it would fit our needs, and to get an API that's what we envision, we need the context receiver, the KEEP 259. So we are really looking forward to this KEEP being implemented into the language. It may or may not be a roadblock. We are currently exploring different avenues to propose an API that's understandable without this KEEP being implemented. But it's not an easy thing to do. OK, and with that, I thank you all. There's the link to the Kodein-DI project in GitHub, should you want to check out it. You have, of course, a link to the documentation here on the GitHub. And there's a link at the bottom of this presentation, which is the presentation itself. So this presentation was, oops, I didn't want to do. Yeah, this presentation itself was actually a website. It's created with JetBrains Compose. It's written in Compose multi-platform. So if you want to check it out, here's the link. And with that, I thank you all for coming. And if you have questions, you can find me on Twitter and on the Kotlin Slack. Thank you very much.